Good afternoon, everyone. My session's name is How to Build Affordable Panoramic Camera Product with Bubblegum96. So here's the agenda today. First, I'll give a brief introduction and the goal of this project. And I would like to share something about what we have done and what we are going to do. And the last one, the performance benchmark. First, introduction. Who am I? My name is Bubblegum from Uc Robotics, and my email address. I'm a software engineer and a community manager of Uc Robotics. And actually, me myself is a maker. So, who is Uc Robotics? Uc Robotics is a high-tech company. We are focused on intelligent platform system integration and development of embedded system. So there will be three keywords of Uc Robotics. The first one, intelligent platform. So Uc Robotics is the manufacturer of Bubblegum96, which is the fourth commercial edition 96 board, and the next keyword is solution. We have 3D cloud printing solution, robotics solution on ARM, which I have demonstrated on the last Connect in Hong Kong. And the third keyword is open source. We have much contributions to the open source world. And what is Bubblegum96? It's a fourth commercial edition 96 board, and it is optimized with Actions S900, and the CPU frequency is up to 1.8 gigahertz. And the SoC was embedded with Imagination's PowerVR GPU, which support Opencl, Opencl, and Opencl. And the display is integrated HDMI with 4K output. And on Bubblegum96, there was a Wi-Fi Bluetooth chip. And we have USB 3 Type A port, USB 2 Type A port, and micro USB 2 port. At the commercial edition 96 board, we have 40 pins low-speed extenders, which provide the power supply, system DC in, ground UR, I2C SPI, PCM, GPIO, and 60 pins of high-speed extenders, which provide SDIO, MIPI-CSI, MIPI-DSI, I2C USB. About the operating system, we have Ubuntu Core, which is a tiny Ubuntu for Internet of Things, and Android 5.1 Lollipop, Linux distributions such as Debian, Gentoo, OpenSUSE, and desktop-like Android Remix OS. So this is the goal of this project. If you search on the website or Amazon.com, there will be lots of panoramic cameras, and I've listed three most popular of them in this slide. And the price will be at the below, but it's very expensive. So we would like to make an affordable panoramic camera. So we use Bubblegum96. It will be just $89, and the motherboard board, I call it camera set. It's about $30, and the whole project will cost less than $120. So the software part of this project. First, the base system is based on Debian 8 JC and Imagination DDK inside, which supports Opencl, and we use OpenCV. Of course, it's linear overlay, but doesn't matter. And we modify OV driver. So here's the camera driver architecture. We use ISP sensor and OV sensor. I think you are familiar with this architecture, and kernel will probe, and the sensor will be probed by the kernel module, and with SoC camera and V4L2, it will be abstracted to a V4L2 sub-device for their user space application to use. Just the simple API like open, IO control, or close application can use a device. So here is the OV sensor initialization timing. The picture on the left is a screenshot from the data sheet of OV sensor, and we have solved the initialized timing of DVDD, OVDD, DVDD, DOVDD, AVDD by hardware way. So in software, we just care about the power down and reset. We use a set GPIO level function to do that. But the pin definition will be definited in the device tree, so the user space cannot modify so it cannot be modified in the user space. Here's the whole infrastructure of the whole project. At the top of it, it's the application with a Fisheye transformer algorithm and sketching algorithm, and below it, it's a QP middleware. That I will be explained in the next slide. And we use Opencl to do the acceleration, and the base system is on the bottom. So what is QP? Actually, we have ported QP middleware to Bubblegum96. QP's full name is Quantum Platform. We use QP C++, which is one of the QP family. You can use QP C++, QPC, QP Nano framework, and the official explanation is it's a lightweight open source software framework RTOS to build reactive real-time embedded applications as a system of cooperating event-driven objects. That will be complicated. So the Qt is a state machine. The picture below is either state sequence for wake up and pause of this project. From the right to left, if you give a wake up signal, and the display will wake up, and give a process wake up signal, process will wake up, and give a camera signal, camera will wake up, and pause is the same way from left to right. First camera pause, and process pause, and display pause, and the whole system pause. So here I will talk about the GPU acceleration because the SoC S900 is embedded with Imagination Power VR. We have 64 compute cores, and their GPU frequency is 528 megahertz, and the shared memory is 4K byte, and the GPU supports OpenGL for the most mobile GPU support that, and OpenGL is a standard Linux OpenGL, and Opencl which we will use in this project. So here's an Opencl code instruction. First, you need to discover and initialize platform and discover, initialize a device, create the context, create command queen, create device buffers and save, and write the host data to the buffer, create and compile the program, create the kernel, set the kernel argument, configure the work item structure, EQ the kernel for executions, read the output buffer back to the host, and release CL release resources. As we use fisheye camera in this project, we need to do 2 steps to make the fisheye perspective transformation. First, correct the fisheye distortion by spherical projection and perform the inverse mapping. So when we do that, you will have a rectangle pictures. The next step we need to do in the application is panoramic sketching. We have 2 pictures here. One picture on the left, they are the captures of the fisheye camera, and the picture on the right, it's a picture when panoramic sketching. So the right picture you can see separately. The left half is either capture from the left fisheye, and the right part is the capture from the right fisheye. You can read the reference reading in this link. So what we are doing for hardware, we are going to make a dual MIPI camera modeling board, and it's open hardware. So this is the schematic. Actually, we have already produced 3 versions of PCB. The first version, actually, it's not working at first, but we found we missed M clock, so we add the crystal oscillators, and one camera can work. And the second version, you know, there is just one ISP sensor in Bubblegum96, so I cannot control 2 cameras at one time with 2 lanes of I2C. So I need to connect to the 2 lanes of I2C together and control it by different register address. That can be done by software. So we connect the 2 lanes of I2C in the second version, and it's working. It works, but it's not works so well. So we made the third version, but I don't know if it is because the problem of the connector. The third version is not working at all. So well, we would like to make the 4th version to see if it is a design problem or hardware problem. So this is a roll capture from the fisheye camera. Since we use a fisheye camera, we need to calibrate to calibrate it. Fisheye camera is different from one-to-one. So when we calibrate it, we have the parameters, and we give them parameters to the sketching to the transformation program. In calibration, we are not care about the speed, so we use Opencl in this section. Fisheye camera module is provided in Opencl, so we use Opencl to it. You can read the reference document in this link. So the benchmark is simulated because the hardware is not ready. Actually, the GPU the sketching, transforming use GPU is 8 times faster than using CPU. So think that will be my session. Thank you. If you have any question. Okay, thank you.